And now for the last part, for this guy. Well, it's pretty much the same thing as we saw with the Mercury Megaminx. See if these all line up. What I want to do first is I want to get all of these edges in place. So what I'm going to do is understand that by rotating it just adjacent to a fixed center, I'm going to be rotating these guys around. So I'm going to bring this over here. This isn't going to change, and I'm going to rotate it until I see a beige right next to this. So 1, 2, 3, down. There's the beige. So move it in. Okay, we got these guys. I'm going to move this over here. I'm going to keep rotating it until what's right next to the beige is the blue, until I see the light blue. 1, 2, 3, bang. There it is. And so everything is in place. All right, that part is conquered. What about these guys? Well, same kind of thing. I'm going to look for the arrow formation, which we actually already have. I'm going to do this in conjunction with surrounded by sides that are fixed, that are basically bandaged. And I'm going to do that same protocol that we did. This should move it into place. So F, R, U, R, I, U, I, F, I, and all these are in place. If they weren't, then you'd follow exactly the same protocol. So these are flipped in place. Now we just have to flip these guys. We do the same algorithm that we just did to move these guys, only now it's going to be adjacent to an area that's not fixed. And it's exactly the same thing. I'm going to move this into here, and I'm going to keep doing that until I get the orange, which is right here. So boom, 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 1, 2, 3, bang. Not yet. 1, 2, 3, bang. There it is. So now I'm going to move this over here, and I'm going to rotate it again until they're all in place. So here we go. 1, 2, 3, bang. These two are the same. These guys are not. One more should do it. 1, 2, 3, bang. And lo and behold, it's all in place. So now the last part of this step would be doing exactly the same thing that we do with any Megaminx, whether they're crazy, whether they're circle, whether they're just plain Megaminx. It's exactly the same thing of rotating these guys back in and then putting them in. The only caveat I'm going to say is just do it where you have bandaged, fixed centers in front of you and to the right. But I'm going to hold it like this. I'm actually going to rotate this up. Well, no, this is already in place, so I just need these two. This has to rotate clockwise. So that's UI, that's RI, UI, RU, RI, UI, RU. There it is. Rotate this here. This is going counterclockwise. So UI, RI, UR, UI, RI, UR. And through the magic of algorithms, it worked, and none of this got messed up. It's a beautiful thing. And of course, the last part, as you know, move these guys into place. I'm going to move this down here. I'm going to move this out, bump this here, here, and here. See all previous tutorials on how to do that. But anyway, I want the pink and beige. So move the pink and beige in place right here. Bang, bang, bang. Now I want the pink and green, which is right here. There you go. Now I want the, well, okay, so once you have this, if it's kind of out of sync, what you do is you just replace it with another one that's out of sync here. Now I want the blue and beige, which is right here. Boom, boom, boom. Blue and orange, or light blue and orange rather, which is here. Bang, bang, bang. Okay. And we have ourselves the outer shell. Now the next part, filling in these guys, and this is where the marathon actually comes in at. And the good news is, well, remember when we did the Mercury cube, we had its very own algorithm, which you'd never seen previous and you'd never seen since. But I'm happy to report you don't have to use that one. You have to do an M maneuver, which you can't use with a Megaminx. To do the Mercury algorithm, you always have to have one side that's fixed and an opposite side that's not. And in this case, because of the variability and the unique Megaminx shape, you'll always have that. So you're going to be able to do You know, if you just had the Venus cube, all you had was this to go by. But now you don't, because you got this guy, and you got, well, not this guy, but this guy. So the algorithm is exactly the same. It just means deconstructing the cube in specific ways. And well, here's an example of what I mean. When you're going to do it, just make sure that you're doing it just opposite a site that's bandaged, that's movable. So let's say we wanted to do, well, we'll start off with the pink here. Let's say we wanted to put this beige over here. So I'd like to put it here, but unfortunately it's going to be opposite this side, which is fixed, so I can't do that. Instead, what I'm going to have to do is I'm going to have to move it here and up. That way it's opposite a side that isn't. Now, it might seem like I'm getting kind of convoluted with deconstructing it, but actually it's fairly easy to figure out how to put it back in because you have a lot of non-overlapping areas. So this will come here. This green, can we put a dark green to accept it? Sure. I'm just going to move this down here. It's a three-way. This will go here, this will go here, this will go here. And I just have to remember to put this back up, and then the rest should follow. So this is a left permutation, which is LI, UL, FI, LF, LI, brings that here, move this in here, putting this in line. Then we have L, FI, LI, F, LI, UI, and then L, puts that back in. Remember to bring this across here. Remember to bring this up, and then you can kind of see how it's fairly easy to figure out how to construct it back. And that's how you do it. And you just plug away, and it actually goes a lot faster than you otherwise might think. So here's another green, a dark green. Let's see if we can move a dark green into place. We can, but it's opposite here. We don't like that. So if we were to do that, we'd have to go here, here, and then up here. So an example of the right permutation, this will go here. Do we have a yellow one that we can put in place? Sure. Over here, just have to remember to bring that back down here. So over here, here to here, here to here, here to here, a three-way. And as you recall, this one on the right permutation is R, UI, RI, F, RI, FI, R. I'll put that in here, bring this back here, RI, FR, FI, RU, RI, and remember to bring this back. Remember we put this over here. So now we just kind of find our way home. This moves here, this moves here, and there we have it. Okay, so I'm going to pick it up from here. I actually put in most of them except for maybe 1, 2, 3, 4, 5, maybe 6 to go. It's actually a lot quicker than you might think. It took me maybe about 20, 25 minutes to get to this stage. What I found is that with the cubes, it was a little harder finding your way back home if you were too convoluted because a lot of the layers overlap. With the Megaminx, you've got a lot of non-overlapping layers, which brings a higher degree of variations that you can do. So you can see my white side, which is usually what I use as my base to do the rotating, is already done. My pink side, also fixed, also with moving center is done. This one is not. So let's see what I can do. What I may do is use the pink one to start moving things into place. So I'll move this here, try to find the green one perhaps. Here's the green. Move this up here. I can't do it from this angle because this is non-moving. So I'm just going to move it here and here. Seems kind of convoluted, but it's a little easier than you might think to find your way back home. This green will go here. This will go anywhere where something's out, which in this case is over here. So I want to simplify it as much as we can. So this is the R permutation. R, UI, RI, F, RI, FI, R. That's in place. Hopefully I didn't just break something there. Bring this in. RI, FR, FI, RU, down and down. Well, then we just move this back here and just kind of find our way back home. This looks like it belongs here. This looks like I can put this here and put this back down here. So you see what I mean about finding your way back. So not too many more. How about we move this here? See if we can't finagle this down to here. Move it here. I can't do it from this angle because this has to be a bandage side, so I'll just move it up to here. And then here we go. So this to go here, this I need to find a, is that a beige or an orange? I think it's a beige. Find a beige one. When I run into trouble like this is going to be a switch for a switch. So I'm going to want to move this down to here. And the way that I'm going to do that is turn it like this, and then go 1, 2, and turn it back. So it'll meet up with that. Might seem convoluted, but it's not too hard to put back in. So an L permutation, Li, U, L, Fi, L, F, Li. Okay, then bring this up. L, Fi, Li, F, Li, Ui. Bring this back down, bring this here. So to move it back, I just have to remember what my techniques were. I had to move this in, so I'm going to move this once like so. Move this here. Okay, yeah. Move this twice like so, because I had this over here, as I recall. I'm going to move this back up to here to match this one. Move this back here because I noticed the pink here. And I'm just going to sort of very intuitively try to find my way back. This pink matches up to here pretty well. I don't think I want to do that quite yet. But why don't I match this over here so I can match these, and this will come down here. So that actually did pretty well. And I gained pretty good ground because I think I just have 3 more to go. This one, and this one. So how can I position these? Well, I can obviously try to put this red one in. 1, 2, bring it here. I can't move it in like this because of this white layer, which means I have to move it across once and then up here so that I can still move it in line here, and so that it's across from a layer that's moving. So this red goes to here. This green, I'll tell you what, we'll move this one up so I can substitute it with this green one. I just have to remember to move it back down. So R, UI, RI, F, RI, FI, RI, that's in. Bring this here, RI, FR, FI, RU, down, down, and remember I had to move this down like so. Now that I've done that, let's see if I can't intuitively put things back. This looks like it would go over here. This looks like I can move this into here, which means I can move this back here, and this goes back here. Alright, so it took a little bit of doing, but what I ended up with is I have this, and these are the last 2 that need to be put in. So, how can I manipulate that? Well, I could put this in here, but I've got this white one that's going to screw things up. So move it across, and move it up, so I can be opposite of a fixed banded side, and then move this across here. So it's a matter of moving this green to this green side. This blue, I need to put a blue one into place, which means I need to somehow move a blue here or move it here. And my technique to do that is I'm just going to move this one in by moving it over and then going 1, 2 and moving it back. And this should be a game solving move here. So Li, U, L, Fi, L, F, Li. Don't worry about that. This comes back in here to match that. L, Fi, Li, F, Li, Ui, down here, down back here. Then I put this back in. It's pretty easy to see that I turn this over here, turn this back. This puts these guys in. I'll just turn this twice so that these guys all match up. And now it's just a matter of turning this here and turning this back. And it's solved. You have solved your Venus Megaminx. Again, just like the Mercury Megaminx, it's more a question of stamina, but what I really enjoy about this puzzle is the multiple techniques of placing edges and just how to deal with bandaged and non-bandaged sides. I would imagine that the Earth and the Mars is the same concept. You just have to finagle your way as to how to deal with 2 bandaged sides at the same time. Whether I do a demonstration on that or not remains to be seen, time pending, but you can probably apply the same concept. So, have at it.